Have you ever tried to pull apart a pair of scissors? You might think they would separate, but with quarks, the opposite happens. If you apply enough energy to break them apart, you don't get free particles. Instead, you create brand new pairs. Let's explore this strange rule of nature. In our universe, quarks are the building blocks of protons and neutrons. However, unlike magnets where opposite poles repel when pulled apart, quarks experience a force that actually gets stronger as you try to separate them. This phenomenon is known as color confinement, meaning they are permanently stuck together. Imagine a rubber band connecting two quarks. As you pull them apart, the rubber band stretches and stores more energy. In the subatomic world, this gluon fields acts like that rubber band, resisting separation with increasing force, the further you pull, unlike any other fundamental force. Here's the surprising part. If you keep pulling until the energy in that stretched field becomes massive enough, it doesn't snap to free a quark. Instead, that concentrated energy spontaneously converts into mass, materializing as a completely new pair of quarks right where the bond breaks. So, you end up with two pairs instead of one. The original quarks remain bound to their new partners, maintaining the rule that isolated quarks do not exist in nature. No matter how much force you apply, you simply iterate the process, creating more confined pairs rather than freeing them. This principle explains why we can never observe a single quark in a lab. Physicists often describe this as the strong nuclear force snapping into new pairs. It is a fundamental limit of our universe where adding energy to the system creates more matter rather than separating existing components. Ultimately, trying to separate quarks proves that some things are meant to stay together. The universe ensures stability by converting our effort into new matter. It is a fascinating reminder that energy and mass are deeply interchangeable, even at the smallest scales of reality. So there you have it. The strong force creates more pairs instead of separation. What other physics rules seem impossible to break? Let me know in the comments. If you enjoyed this deep dive into particle physics, subscribe for more educational content.